here. Oh, okay. Well, the Deep Dixie Contest Club wants to welcome all of you for this presentation tonight, and we thank you for coming. We know you had a lot of choices to make, so I know we have members here from the Dallas-Fort Worth contest group, the 599DX Association, most of whom are in Mississippi. A lot of them are along the Gulf Coast of Mississippi. For the 599DX Association, we have members of the Tennessee contest group. We have many of you who are co-members with us of CW Ops. And then we have a special radio group here in Northeast Mississippi that likes being a club, but they don't want to have meetings and they don't want to have officers. And so that's the Area 51 radio group, and they are doing great work. They just meet when they want to. I know we have members of the Society of Midwest Contesters from the PVRC, and I'm not sure what other clubs. So I don't know how some of you got the message, but I surely do appreciate it. And if it's okay, I will continue to send out these notices for our upcoming presentations. One of the announcements that I have for tonight is that we have another presentation coming up, and tentatively, we have that set for 2 weeks from tonight, Thursday, October 22nd. If there are any compelling reasons why we should move that or change that, we can do that. But Jerry Hull, W1 Victor Echo, has a presentation that he volunteered, and so we'll look at that information in just a moment. Nirvana, RS-232 Nirvana for the radio contester. And then we do have a Google Sheets for presentation requests and ideas. So if you have some requests or ideas for presentations that you'd like to hear someone give, and you can't find that, then just send me an email at nn50larry@gmail. So the previews of that coming distraction is right here from Jerry Hull, W1 Victor Echo. And in the event that you can't read my little screen, it says every contester uses RS-232 and USB in the shack. RS-232 as a native device is not available on most desktops and 0 laptops. We all know the nightmare of USB to serial ports. This talk is about eliminating USB to serial from the ham shack and using surplus but modern serial port server technology to completely eliminate the problem. And Jerry will go into how it works, what's available, and how to use the technology both in your local shack or to remote your automation around the world over IP. And he says he's delivered this presentation to multiple users around the globe. So also, we let you know that the Deep Dixie Contest Club is proud to have a very small, but hopefully quality collection of YouTube videos on our YouTube channel, which is simply the Deep Dixie Contest Club. You're welcome to go there and see them, and you'll see a couple of really great presentations we've had not long ago. One was the previous presentation by Kevan, N4XL, who's presented tonight. And then we had a presentation a few weeks earlier from Dr. Tor Clay on spotting, using spotting, and he wrote his own software to do that. So all that stuff is there. This is not a very update slide, but nonetheless, I forgot to fix this screen when I said here's Tor. So I'll actually what I'm going to do is to quit and hide that and stop sharing my screen so that we all can be ready to go. And just give me time to do a little housekeeping here. And so I hope that's going to be all right with everybody. So Kevan, on behalf of the Deep Dixie Contest Club and the officers, I want to thank you and welcome everybody to the presentation. And we're so glad to have so many people here. Kevan, so that you have plenty of time, I want you just to go ahead and feel free to launch off, and I'll try to sort of manage the farm here a little bit. I would say, no, Kevan, you tell us how you want to handle questions or comments or suggestions that come up.
Well, I've managed to get my chat thing up here and running. So that is one way you can do it if you don't want to shout out. But as far as I'm concerned, if you have any questions while I'm giving the presentation, just give a shout and we'll try to interrupt here and answer your question if I can.
That will be great. Okay, when you get ready, just go ahead and I wasn't sharing my video, so that's pretty good. So y'all don't have to succumb to my ugly face. All right, take it away, Kevan Nason, N4XL.
Well, first off, I'd like to say hello to everybody and thank you for coming. Are you seeing my shared screen okay before I go on?
Yes, we are.
Good, yep. Glad to hear that. Now, I do got to start out here with kind of a disclaimer a little bit. This was a presentation that I've given to 2 or 3 local clubs, and it was targeted more at the beginner intermediate people and not at contesters. As such, you people who have 4 squares or shunt-loaded towers or things along those lines, you may not get a lot out of this. There is some things in the second half of it. Those of you may know N4XL Rudy has done a tremendous amount of work on verticals and measured performance of them. You may get 1 or 2 things out of there. Some of the old timers that were in these other clubs said that was fairly new to them for the most part. But this is not a presentation which is going to tell you how to build the best antenna. My idea behind this is more or less to take people like me who are little pistol stations, and when I started looking at how to improve my 80 and 40 meter, 160 meter performance in contests, I didn't have the solid background that I really needed to understand how to make the antenna sing, if you will. And I don't have the resources that many of you do. I don't have the room for 4 square. I don't have the finances to put it up. So when I started looking, I started to have to make compromises. And you hear things like, just put out as many radials as you can or make your antenna as tall as you can, but I'm uncomfortable going to a lot of work just to find out that that wasn't quite good enough. In fact, at one point I'd put up an inverted L, and I had a 30-foot vertical section and a 100-foot horizontal section, which at the time was all I thought I could do. And I put out 8 radials, and I was pretty disappointed with it. And then I bumped it up to 16 radials, and I was still disappointed with it. So when I took a look at the contest scores, and I said, I've got to do something about 80 and 160 meters, I broke out the books, I broke out the mouse and started looking. And these are some of the things that I ended up learning a little bit. So this is my learning experience as I went through learning how I could make some vertical antennas work here in this lousy ground system that we have in upstate South Carolina. See if this thing will start working. Alrighty, so the goal, I could model it, and that was what I started out to do, but I realized I didn't have the skills to trust what I was modeling. So I started going out and finding all these other sources. And we're going to talk about factors you can control that affect the antenna system performance and the measured and calculated data that's out there available to you that could be useful in making some of your decisions about how you want to put your antenna up. Many references, N4UN, of course, the ARL books, Jim Brown, K9YC, some things out of Joel Hallis, W1ZR again, and Rudy Severn's N4XL. I relied a lot on him for the practical information for the decisions that I made. This beginning part here, am I still making it? I'm seeing all kinds of weird things happening. Is my screen still there?
Your video has disappeared.
Larry, are you doing things up there? It says Zoom cloud meeting.
I'm not intending to.
You've got a Zoom cloud meeting sign-in screen.
No, I don't. That's because I'm signed in already.
Minimize your
I'm not
browser.
doing any of that.
Oh, yeah. Okay. We were watching Mike in N9AJ or something, watching that channel. So let's just
Let me try again.
let's make sure we're hanging in here with Kevan.
And now, Kevan, you're showing yourself, but not your screen.
Okay, how about this?
There you
we
go. There you go.
Okay, thank you much. Yeah, I noticed that it kind of disappeared on me while I was talking. So this beginning is a little bit of repeat for people who know quite a bit about vertical antennas, but it's needed to understand some of the information later on at the end. Let's see, this thing stopped working again. There we go. One of the questions you get kicked out a lot, and us contesters understand it, does 1 dB matter in transmitted signal strength? You ask anybody who's not a contester or DXer, and they'll say, nope, you need about 3 dB to make it worthwhile. But those of us who do a lot of that contesting in DX, and we understand that if you can make several 1 dB changes, or even a couple 3 dB, several of them, you end up getting a pretty significant increase in your signal strength at the end. So well, every 1 and 2 dB counts as you go through this. Dipoles, of course, are affected by height. This is kind of the ARL manual, talks a little bit about the different things. And I put some heights up here in red for an 80-meter dipole. And a lot of people think a 66-foot antenna, one that's up 66 feet in the air, is pretty good. But if you look at that center thing there where it says B, you don't get much of a low-angle DX antenna signal coming out of there. Works okay for the US pretty much, but you have to get up down there at about 132 or 165 feet to make this worthwhile. And one thing that people say is verticals don't work very well, but if you take a look at these graphs, and these are just generic things, you can see that at 5 degrees, an 80-meter antenna dipole is minus 20 dB if it's a 66 foot, and still minus 10 dB at 132 foot. And the takeoff angles for DX come in at those low angles. So a vertical is a pretty good choice when you start comparing to these things, unless you can get a dipole really high up in the air. And we're ignoring ground effects, by the way, too, because some people mention that. Verticals, on the other hand, are affected by the type of ground. One thing I hear all the time is vertical doesn't work very good unless it's on salt water. And this little screen here talks a little bit about that. The purple is salt water, the green is very good soil. Here in South Carolina, we're a little bit between the blue and the black, average in rocky sandy soil. So we don't get those super vertical wonder antennas that you hear about and they write about in QEX and stuff like that. But when you consider that minus 10 to minus 20 dB angle that we just showed in the previous slide, it doesn't take a lot to improve over that. So even though we have average soil or rocky sandy soil, I started taking a good look at the verticals and said, if I can make this thing play a little bit, I can probably come out a few dB ahead. And even if it's only a few dB, like we talked about, they add up and increase your signal strength at the end. These charts are available. This come out of Larry Seebeck. A lot of people respect his opinions before RNL. And these are what he used for his measurements for the ground soil conditions. I'm going to refer to that 0.002 as just 2 and 5. And if you take a look at some of the stuff here we have here in South Carolina, I am located, let's see if I can make this laser pointer work. I'm located right up here in Greenwood, so I'm in a 4, but a lot of the people I talk with are here in Columbia and down here in Aiken. They got horrible ground. So no wonder people say a vertical doesn't work very well. They have to do something to overcome that a little bit. And let's see. One thing that I pointed out to them is those are not hard numbers in those regions. You end up having a range of conductivity and permittivity results in these things. So you might find yourself, even though it says you're in a region 2 or region 4, of having a much better ground condition. In fact, one of the guys that I talked with when I was given a talk to the Dutch Fork group here, which is in the center there where it says Lexington, said for some unknown reason, he had a real good ground system, even though it said number 2. and he was able to make all kinds of contacts using a vertical. A neighbor his hammed on the road about 2 or 3 miles, didn't have those same ground conditions, and he couldn't talk to hardly anybody, even though they had almost the same identical antennas. They patterned it off each other. So the ground can make a difference. And there's got to be some other way to overcome these types of things. So if you look at this comparison a little bit, overlay the vertical and the dipole, you end up seeing down here at 5 degrees, you get quite a significant increase. If you follow those curves around, works out to be about a 10 dB gain increase. 10 dBs is pretty significant. That's like running a kilowatt amplifier. And if you end up getting reciprocity of transmit and receive, that helps you out on receive too. And if you can't get down there at those low angles, which some of us can't, a lot of people says that it's useless to try a vertical, but even at 15 degrees using this particular comparison chart, you still get a 3 dB improvement. So I started looking at this and saying, all those old timers who said verticals don't work in South Carolina, maybe they're just not installing them correctly. And that was the direction that I started going. NRL has also put out a thing. People like to use tuners a lot to match their antennas. And many people, if they're not familiar with it, they just throw an antenna tuner in, they look at that 1-to-1 SWR. But the NRL put this information out for T-network tuners, which are not the highest efficiency. You get 85% loss out of your tuner. Works in your favor definitely to make an antenna match as close as you can. But if you can't, start taking a look at the loss factor. How much inductance are you putting in there? If you got a short antenna, you're going to have to put inductance in to compensate for it. And that ends up giving you the higher loss percentages, whether you're doing a T or an L match tuner, it turns out. So if you've got to put an antenna up, don't use a short one. And if you think about the commercial verticals you can buy, a lot of them are only 18 foot tall and you're trying to use it on 80 meters. Some of them put a top loading on it or a coil and try to use it on 160. That's really short. That's giving you some issues as well, which will come out a little bit later on about radiation resistance. So I started looking at this and I thought, well, that kind of tells me I need to make these antennas much longer than I was used to. And that's a good reason why. Here's a graph, which some people may not be thinking of too much about elevated radials. You hear that only use 2 or 4 of them. But an 80 or 160 meter antenna is not going to cover the entire band with 2-to-1 SWR. If it is, you got some other problems going on. But if you take a look here at this graph also, that's 2 radials, that's 4 radials, and this is for an elevated radial system. The more elevated radials you put up, the wider your bandwidth is as well. So that encouraged me to start thinking maybe I ought to use more than the standard 2 or 4 radials if I go with an elevated system. We got some more data on that a little bit later on. So when I started looking at that, I got a little bit encouraged and said, maybe this is worthwhile pursuing. So I sat down and says, what exactly do I want to do and what do I have to do it with? I'm looking at 80 and 160 meter DX in all directions. I've only got the place to put up one antenna really, and I don't have a 100-foot tower. What I do have out there is a tree up about 65 foot. I've got 2 or 3 of them. So I could use a dipole or I could use a vertical. When we look at that dipole and that low takeoff angle radiation, so I'm kind of looking, can I get a vertical in there? I've got about 1.5 acres, but the XYL doesn't like wires going around everywhere. And across the back quarter of it, I've got an elevated power line as well. So I've got some limitation on my lot size. And if I need to, I can talk to the XYL and say, look, I got to have this. And she understands, but I try to keep the peace as much as possible. So I started looking at what I could do without putting a vertical up right in the middle of the yard. And I'm a low power station, so I don't run 100 watts or 1,000 watts. And that gives me a little bit more latitude with things like antenna tuners or matching networks and things. The tool I needed, as we've already talked about here, is a vertical. And you'll have to excuse me a little bit now and then. I'm suffering with some allergies, and that's making my throat a little bit raspy from drainage. I apologize for that. Again, local people say verticals, they don't work very well here. And I was left with the thing, do I accept their tribal knowledge, or do I really take a look and figure out how to make it play well? I ran across this saying from W8JI, Tom Roush, just about everybody ought to know him. And he said it over and over and over, there's no free lunch. Well, I used to try to get that free lunch, but decided to take him at his word and start seeing I guess I got to do a little bit of work here. There is a book out there, HF Vertical Performance Test Results, Ward Silver, and I forget the K7LXC's name. I used to know it real well. They put this book out. It's available from Champion Radio, and it's really worth looking at. I pulled one little section out of it here, and it talks about an 80-meter gain, what they had measured in their particular thing. And the boxes that are in orange were for verticals that use radials, and the blue are the non-radial systems. And right off the bat, you can see with those gain figures, it's not worthwhile trying to get a radial out there or a vertical out there that doesn't have any radials. Tom was right. There is no free lunch. You got that little outlier there, the CP6. Well, how come that one's doing so bad? It's only 15 feet tall. So that also kind of lets you clue in that if you are going to use a radial vertical, you ought to start looking at getting the thing tall enough to make it more effective also. So that's a real good book to go through, and I encourage you all to pick that one up. Here's my antenna tower, if you will, that I use for my vertical. Inverted L is one that I end up using. I got about 65 feet up and 60 feet going on the L. And if you notice, it kind of swings out here away from the tree a little bit. K2AV talks about having a loss of 3 to 4 dB if you run that thing up the tree. I know in one of these antenna compendium books, there's a guy ran his wire right up the tree trunk, and there's been a lot of talk on some things like the 160-meter reflector and stuff about do the trees affect it, and it does. And another thing I've learned since I put this thing up is if you shoot this horizontal section across the tree, and it's going right across the tree, again, K2AV is measured about a 2 to 3 dB loss for that. Would have been much better for me to put it off in this direction without having anything there. But I talked to the XYL. I was looking at an OCF dipole going across here, and she really didn't want to see anything above the house. So I didn't think that was too much of a compromise to make for her. So I talked to the neighbor. He said, sure, go ahead and run that over there. No problem whatsoever. And I ended up with 40 buried radials. We'll talk about why as we go through this. I've since added about 5 or 6 more, and I'll probably add some more as time goes on. But that's my layout here. Can't see it, but I've also got an elevated vertical. I'll show you in a picture in a minute. It's up here in this section. It looks like that right here with a feed point right here at about 20 feet tall, and it's got some elevated radials coming out. Right now, I think I've got 10 elevated radials for 40, and I've currently got 6 for 80. I'm probably going to put a couple more of them up a little bit later. We'll talk about why more than the standard ones there too as well. So how do verticals work? You got a near and a far field. Near field, basically, by the way, I don't have my picture anymore if anybody's trying to send me a chat. So if you have questions, feel free to just shout out. The near field's right next to the antenna. The next to, typically that means within about 1 wavelength of the antenna is how I look at it a little bit. Then you got the far field. This far field is out there 2 or more wavelengths away. And it's because of this far field, you get losses out there. There's another reason that the old timers say vertical can't work, because you got all those far field losses out there. There ain't a darn thing I can do about the far field losses. I mean, if you take out 2 or more wavelengths from a 160-meter antenna, heck, I can't do anything about the ground that far out. So I decided to ignore it. Some people are uncomfortable with that, but I basically looked at it this way. If I can significantly improve the near field signal strength, regardless of those far field losses, I've got more energy goes into the far field. I'm going to get more energy goes out to the far field. So I started looking, how can I go about maximizing my near field signal strength? And another good phrase that I ran across was from Jim Brown, K9YC, don't let your inability to make a perfect antenna prevent you from making an effective one. And did I end up we'll jump a little bit ahead here. Did I end up making an effective antenna? This is anecdotal, but I went ahead and looked at entered the 2019 CQ Worldwide CW contest, and I only run 100 watts. I ended up getting 38 DX entities, and you can see I spent a lot more time on 40 and 20 meters. I had 38 DX on 160 meters after doing this inverted L, which is about a 5-time increase over my historical scores for that band. And I ended up with about a 4-time increase on 80 meters, which was a result of using that inverted L, because I also loaded it on 80 and the elevated vertical in the back. So I think that anecdotally, I did pretty well. And you can't judge results from one contest. I also pulled some data out a little bit later. We had the CQ160 and doing search and pounce, although this was mostly domestic. I was doing 90 stations an hour on search and pounce and some sustained runs, which are about 10 to 15 minutes at the 80 an hour rate, just by running 100 watts. So I figure that I did do fairly well in improving my 80 and 160 meter antenna performance. Transmitter generates 100 watts. Where does it go? Unfortunately, we lose too much of it. But what are these losses? Where does it go? Antenna inefficiency is part of it. And even though you know this intellectually, SWR does not indicate antenna efficiency. You still look over and you see that SWR meter down there low and you think, I'm doing pretty good. But that's not always the case. We'll look at some figures here in a second. You also have loss in your feed line, antenna tuner loss if you use a tuner, and ground loss. And that ground loss thing is something we're really going to talk about in a little bit. My very first vertical I ever used was at my high school station. And we had a 3-story high school. And on the top of this high school, it was about, I'd say, I think it was 250 by 250 square feet on the top roof. It had a 1/4-inch steel plate on it. And the ham radio operator class, the guy, science teacher, was a ham radio operator, and he got permission and he put a vertical right in the middle of that 250 square foot steel plate, 90 feet up in the air. And it worked killer. So when I got out on my own, didn't have an Elmer, joined the Navy, ended up being down there in Florida. And I decided, well, vertical worked real good. So I bought me one of these 18-foot verticals and put it out there. And I read the manual. It said, you don't need radials for this. And I believed him. So I put it out there. And this is what this reference 6 here says for values. You plug them in. You've only got a radiation resistance of 6 ohms, but you get a ground loss of 30 ohms without any radials. So you've got essentially 100 watts in and 96 watts going straight into the ground and into some of the losses that you get in the center. That's not very good. We want to reverse that ratio and make radiation resistance be as high as we can and ground resistance be as low as we can. Another interesting thing about this is if you look at it, you got 36.5 ohms of total resistance, 50 ohm system. Your SWR for this is 1.4 to 1, but you're still losing 96 out of 100 watts into the ground. That's just an illustration of why you can't trust SWR as being indicative of an efficient antenna system. I talk a little bit, talk a little bit about antenna system efficiency.
Hey, Kevan,
Yeah,
we have a question from one of the viewers.
okay.
N4XL, how did you measure your ground resistance?
We'll get to that in a minute or two.
Oh, okay.
Thanks. How can we improve antenna system efficiency? Let me mute this just a second if I can, figure out how to do that. I need to get a drink of water. Excuse me just a second. All right, let's try this again. Many people look at just one part of their station at a time, but if you're looking at antennas, it's a system. You go from a radio, you've got your tuner in the shack if you do, hopefully not. You got your coax running out to it. You've got the matching network at the base of the antenna. You've got the ground underneath it. You've got the height of it to come up with radiation resistance. They all work together to give you a system. So when I started looking at this proving my station, I told myself that what I have to do is actually improve the system itself and look at every component out there that I can. First thing is you got to have an efficient antenna. You got to reduce your feed line losses. You have to reduce the matching losses, and you got to reduce your ground losses. Look at all them together. This isn't limited to just verticals. The same principles apply to whatever your antenna is. No matter what it is, look at it as an entire system and address each point of it. For years, I had the hardest problem understanding what radiation resistance was. But basically, as I got to looking at it and put it in simple terms, think of it as just a component in your antenna that converts the RF coming out of your rig to stuff to go off into the air. And since it's converting, it's the transducer, if you will, of your RF energy to stuff to go out into the air, the higher you can make that, the more energy is going to be transmitted. So if that's the case, how do you go about figuring out what radiation resistance is? Well, I looked at my MFJ meter and there's this big old R on the screen. That must be it. Nah, as much as I wanted it to be, that includes every loss in your system. That is not the radiation resistance of your antenna. Best way to come up with radiation resistance for vertical, or easiest way, is to go ahead and look at the graph, and they're available in the antenna books and things. Actually, I didn't know this. These things go off even up to the top and increase radiation resistance when you go beyond 90 degrees. There are separate charts for it. I didn't know that. But for a quarter wave vertical, your radiation resistance is going to be 36 ohms. That's a 1.4 to 1 SWR. So if your antenna system has 36 ohms in it, no losses anywhere else, your SWR is going to be 1.4 to 1. It's going to be as efficient as it can for a quarter wave ground pole. The other thing about this is you get those 18-foot antennas again, or like I've got a 33-foot one for my 4080 vertical. That's only on 80 meters, 7 ohms of resistance, radiation resistance. Not very good. We've all heard that top loading is good. In these two charts, this one's center loading, and then that's top loading is better. That's a clear example why right there. You get much more radiation resistance out of top loading than you do out of bottom loading, base loading. It's much easier to make a base loaded antenna, but that's your cost that you end up getting. So top loading is better. Inverted L is a type of top loading. A T antenna is another type of top loading. John, K4BAI, has a great signal. He uses a T-loaded vertical, and I'm sure some of you have too. But if you can make your thing 66 feet tall, that's the way to go. You end up with 36 ohms of radiation resistance. So I started saying, how can I get this thing up to 66 feet tall? And that's when I started looking at the trees around a little bit. Taller vertical is better for improved radiation efficiency and antenna efficiency. Resonance better, so you don't have losses in the components. Top loading, like we said. A lot of people want to use that electric fence wire. Most people recommend avoiding that because it has increased losses in the wire itself. Should avoid traps, use high Q coils if you can. And if you haven't looked at your antenna in a while, look for those loose or corroded parts. Do your antenna maintenance. Part of the system includes the feed line loss as well. We're talking about 80 and 160 meters. Most any type of coax will work. I do recommend you shy away from 5.8 and 8X though. One, it has twice the loss, even though it's still pretty low, but it doesn't have as much shielding as the other ones do, LMR400s, or I'm sure some of you are probably even using some hardline or whatnot. So shy away from them just because of the shielding aspect, if for nothing else, even though they appear to have low loss. Second thing that some of the newer people don't really understand is if you terminate your coax, a long coax run, like I've got about 150 feet going out to my elevated vertical. If you terminate your long coax run in a mismatched SWR, you will get an increased loss simply due to the mismatch. And that's above and beyond the coax loss that you have just because it's coax feeding at that particular frequency too. It's additive to the other. So I started looking at that. I used to use an antenna tuner because I use my antenna on multiple bands. I used it right here in the shack, but that's not the thing to do. If you're going to use a tuner, put it out there, find some way to put it at the base of the antenna so that you don't get that extra coax loss due to the high SWR. Use a graph that kind of explains it. If you have a line loss of 1 dB and an SWR of 15, you get an additional 2 dB loss in that coax just because of the mismatched SWR. Now, some of these things, if we're talking about RG213 or whatnot, excuse me, I need to mute here just a second again. I apologize. Okay, some of these things, 0.35 dB, you can go up to a pretty high SWR and not get a loss. However, when I put this antenna out there, my antenna analyzer showed when I used that 160 meter L on 80 meters, I had 4,000 ohms of resistance. So even though I had 0.35 dB of loss in my coax, that SWR, I'm figuring it gave me, that's way beyond what I can read. I'm figuring 81 SWR. I probably had an additional 10 dB of loss just because I was using the antenna tuner in the shack. Not a very good thing to do. So I ran out there and I grabbed up one of these LDG auto tuners and I got me this little plastic case and I mounted it right there at the base of my inverted L out there by the tree and it didn't work, even though I could have got a 7 dB change. The LDG tuners, it turns out, only have a rating of 6 to 1,000 ohms. I had an SGC 213 tuner here. It goes up to 4,000 ohms. So I threw that out there and it worked very well. I do have an elevated radial, elevated vertical, and I'm unable to get it to tune much beyond about a 250 kilohertz range with either of them. I'm only down about 80 kilohertz without using the tuner at all. So someday I'll maybe find out a way to get a better matching network out to each one of these antennas. But as I said at the beginning, this is not about making the perfect antenna, it's making one that's effective and understanding how, if you decide to use tuners, what are you compromising, what are you not compromising, how do you go about getting the best signal that you can for the route you decide to go, which is what the purpose of this is. Reducing ground loss, we had a question on that. How many radials?
On the previous situation, use a huge loading coil to bring the reactance down near 0 and a transformer to step up the impedance near 50 ohms. Then pretty much any antenna tuner will work with it.
That sounds great. I thank you for that. When I start doing it, I'll take a look at that. Who was that, by the way?
November 8, King Henry.
Thanks. Appreciate that. I'll make a note of that when we're done here and I'll take a look at it. Because like I said, I'm not happy with what I'm doing right now, but I intend to get to that sooner or later. Great idea. Where was I? I'm sorry. Let me get back here a second. So how do we reduce ground losses and how many radials do we really need? The FCC says you need, when they're looking at their AM stations, what was it, 120 of them that are a half wavelength long? I guarantee not in my lifetime am I going to go out into this clay and bury 120 radials that are a half wavelength long on 160 meters. It ain't going to happen. So I started asking myself, how long do they really need to be and how many of them do I really need? Again, this is kind of basic, but here's a current profile of a vertical, quarter wave vertical, and most of the current is down here at the bottom and right near the ground. So you end up shooting a lot of your energy right down into the ground. Top loading, if you can put a top load up here, it forces this current profile higher, gets it out further away from the ground. That's how come that works as well. Much better to have top loading on things. For those of you who have trouble visualizing it, this is what we're talking about, ground resistance. If you can put a conductor in the ground, obviously less loss. So the question come out, This guy says, just put out 8 quarter wave radials. You'll be fine. I can't begin to count the number of times I heard that. But when I put up that lousy 18-foot vertical down in Florida in that sand, that was the first time I heard somebody say it to me. And would I or wouldn't I? I got a lot of people around here still believe that. Here's a graph. Go ahead.
Modeling with Ansoff's HFSS program shows that you get incredibly diminishing returns after about 32 radials that are only a tenth of a wavelength long. In other words, you get almost all the bang for the buck for roughly 32 radials, a tenth of a wavelength long.
That's roughly where I ended up, and we've got a chart to talk about that in a minute or two. But here's this guy that's talking about 8 radials. And if you look at this chart, which was put out, and what a lot of people have quoted to me, it looks at the number of radials and the change in gain or whatnot, and that calculated this out. You end up with 8 radials, you'd have to go all the way up here to about 64 radials to get a 1 dB change. That's not worth putting out all those radials for it. Rudy, N4XL, went out in the park and he set up and he started measuring things. And what he found out is going from just 8 to 32 radials, you end up getting about a 3 dB increase. I can handle putting 32 radials in the ground. And just as an aside, I got to looking at it, and when I had 16 out there, they'd still work out of the ground now and then, and I'd chop them up with my lawnmower. So I targeted 40 so I could lose several of them and still get this type of gain. That's how I viewed that. I'm still going up a little bit more. But if you see this thing starts flattening out a little bit and going again, like was just said, going beyond about 32 of them, you don't get much worthwhile going beyond 32 radials on this particular chart. We'll look at it as a function of length here in a minute or two. Matter of fact, that's coming up next year. This chart talks about equivalent resistance of buried radial systems. You can measure the ground resistance. There are ways to do that. To be honest with you, I don't have the equipment. I've looked at the things a time or two. I could rig something up. I didn't think it was worthwhile for me to really dig into it because, again, it is what it is. I'm not going to go out there and salt my whole yard. I need a pretty good radio field for an 80 and 160 millimeter antenna. So I just wanted to come up with an approximation of where I was. And I use this chart right here. And you look at it, this is for 80 meter lengths, 0.15 radial length. I put the value that's 40 feet long for 80 meters, quarter wave length 65, and 0.4 is 105 feet long. But there are a couple interesting things about this. You start looking at it, the length of the radials has minimal effect until you use more than 30 of them. By that I mean, if you go from a 40-foot radial to a 105-foot radial, you had just 2 of them, you only gain about 1.5 ohms of ground resistance improvement. 15, you only get about 2. When you get into 30 radials, that's when it starts making a big difference in the length of them. So if you can only go up to about 30 radials, they might as well only be, for 80 meters, 40 feet long. It doesn't do you much good to go more than that at all. And that's what this thing's showing you. Until you get up here to about 60 radials or 120, quarter wavelength is probably the longest you want to go. So when you hear people say many shorter ones are better than many long ones, that's why. When I started looking at this, I threw some rough numbers in here just looking at the chart. I didn't calculate this. I just chucked them out there. I figured I'd have about 8 of them, give me 20 ohm resistance, 40 would give me 11 ohms resistance. So that significantly cuts down on my ground resistance. At the same time, I'm making a tall antenna to increase my radiation resistance. I'm well on the way to shifting that imbalance where I'm losing 96 watts into the ground and putting it back up. So maybe I've got 70 watts coming out up at the top now. That's just throwing some numbers out there. Any questions so far? Okay. Next
Yes.
slide. Yeah.
Yes, I have one from Joe, K7JOE. He said, I missed it. What is the electrical length of your inverted L radiating element?
I've got 65 foot straight up and 60 foot out. Now I can't cover everything in the this hour-long session. I've since learned that that's probably not a great length to have. I ran across somewhere that says in about 130 to 137 foot is a lousy length to have for an inverted L. So there are other things out there. And one of the sites I recommend you go to is K2AV. You may know him from the folded counterpoise stuff, and we'll mention that briefly later on. But he has a tremendous amount of information about how to do verticals and inverted L's. And he's the one I mentioned at the beginning about I shouldn't have turned it over the tree. He's measured about a 2 to 3 dB loss in the inverted L if you fold it over a tree like I did. So I highly recommend you go take a look at his website, K2AV. And he's got some information there. I think it was in his where I come up with the length of the inverted L isn't necessarily great. And while we're here, I'll also mention Larry brought up, we were exchanging some emails a little bit, and he gave me a reference to a section which guy was looking for some NVIS antennas. And the guy had mentioned about a 5/8 wavelength long inverted L and how that puts the, excuse me a minute, I gotta mute this a second again. My allergy shots wore off. I'm looking at going back and getting some more of them. But anyway, 5/8 one is put the current distribution into the horizontal section, which gives him much more NVIS. One reason I elected to try to run this inverted L 160L on 80 is it also gives me a vertical NVIS capability that seems to help out with the recent adjacent states. So that's what I end up with. I have 60 foot up and 60 foot out. But again, I highly recommend you look at your own situation, what you're trying to do to come up with those numbers. Here's 160 meter measured from Rudy N4XL. And if you look at this, two things to come out of it. He's going from 4 up in radials, and what his signal strength ends up being kind of follows that same curve, but going from 8 to 32 radials, we said before it gave you about a 3 dB increase. On 160 meters, it only gives you about a 1.5 dB increase. So the lower the frequency you go, the lower the gain you get by putting out more radials. And I don't know, but I'm assuming that has something to do with the ground loss effects that occur and how far the signal penetrates the ground. This is kind of an anomaly. If you read his data, which he has his QEX articles on the internet, he said, I think he said there was a ditch that he had, a little drainage ditch, and he thinks that that anomaly was because of the drainage ditch measurements, but most basically it goes along in that direction. So the higher you are in frequency, if you're looking at like maybe a 40 or an 80 meter vertical or 20 meter vertical, you'll get a bigger bang for the buck out of putting out more radios than you will down around 80 and 160, but still it's worthwhile putting out quite a few of them. He also measures stuff or calculated some stuff for the different soils, number of radials versus a signal improvement for very good ground. If you've got good ground, you don't get as much signal improvement that you do with poor ground. So if you're like in South Carolina where we are, or somewhere else which is really sandy, it's more important that you put out a good radial field because you'll get a much better increase in the gain out of your system as well. Here's the thing that says the shorter the antenna, the more important it is that you put out radials. If you've got a quarter wave, you still get a good signal improvement out of them. Well, we've got a guy here in the Swamp Fox contest group who mounts a 7.5 mobile foot whip on a 6 foot metal ladder and runs a couple of radials out. And he does surprisingly well for what he does, but he gets a tremendous improvement. He says, I really notice a difference when I run those radials off the ladder. Well, this kind of illustrates why. You're using a 1/8 wave, which is a 33 foot tall vertical, top loaded and base loaded. You can see again the improvements that you get. So the shorter your antenna, the more important it is that you put out radials as well. Here's another interesting graph. He put this thing out there and it's looking at the change in gain as your radial length goes out. And he has this would be a field day setup, 4 radials on the ground without a ground rod put in, or 4 rods put in the ground, or 4 radials with a ground rod put in, as compared to 8 radials laying on the ground. Really kind of interesting. And what you end up with here is, if you look at this, if you're going out and setting up a portable operation where you don't have a ground stake, you're better off not having those quarter wavelength radials. You're better off having them be about 25, 26 feet long, because otherwise you end up losing just about 3 dB by going out a full quarter wavelength. Found that kind of interesting as well. So we'll get to elevated radials in a second. But a couple other things we pulled out of this. It doesn't really matter what your diameter of the radials are. It has some effect, but it's not all that critical if you're making compromised antenna systems. 18 gauge is okay. Some people ask, should it be insulated or not? I've read some posts on the internet. Some people get a little bent out of shape about it and say, no, they got to have contact metal to metal, but the whole thing's capacitive anyway. And I decided to go the route of having them be insulated, because that way they don't corrode as fast and they'll last longer buried under the ground. Copper is preferred, much lower resistance, and quarter wave are good for most part. Half wave is often better as far as ground radials go, but the length, if you're burying them, is not critically important. That old adage, you put them out however long you can get them, it seems to work fairly well if you have to do with compromises. I just put mine out. Some of them are 15 feet long, some of them are 100 and 105 feet long, in that range. I get pretty good results out of it. An alternative to ground radials, if you don't like trying to bury them, which, by the way, in some of the other ones I get asked, how do I bury my ground radials? You can run a ditch witch, or you can use those trimmers, or N4XL has a thing in his book where he sets his daughter on a on a little metal thing, and he drags it behind with a tractor and cuts some grooves. I did the old shovel, 6-inch wide shovel, and went out after good rain and buried 2 or 3 of them, and then the clay hardens up again and wait for the next rain and put out 2 or 3 more. That's how I end up doing it, and I can get them down in the ground about 6-8 inches, and it works pretty good. But if you don't feel like doing all that work, you can look at elevated radials. Elevated radials will screen the earth so the antenna doesn't see it as well. But in this case, you got to have the radials be to the right proper length. It's critically important. It's actually the other half of an antenna, think like a dipole. You need both legs of dipole the same way, and you need that same thing, tuned radials for going up for something else. You'll see a chart here in a minute or two. I think I left it in here where it says the elevated radials only got to be 2 or 3 feet off the ground. But N4XL recommends that you actually have about 10 feet for 80 meters and 18 or 20 feet for 160 meters. He's found that the elevated radials played a little bit better when they're elevated up off the ground. And that was one way I used to have my 40-80 vertical at about 8 feet, and only had 4 radials on each band. But since I've bumped it up in the air and put it about 20 feet up, and like I said, I think I've got 10 on 40 and 6 on 80. Anecdotally, I'm getting much better performance out of it than I was. And I did have a much broader band SWR with it down lower than I do now, which kind of indicates to me that it's performing much more like it should as well. So you might consider raising your elevated verticals up to 10 feet for 80 meters and 20 feet for 160 meters. Here's a graph, talks a little bit about the radial number as a function of gain improvement. This was for ground radials that we looked at just a little bit ago. You can see for 42 of them, you get about 5.6 dB of gain. But if you have elevated radials with just 4 of them, you can get that same gain when it's only like 3 feet off the ground. I think this was calculated information, not measured information. So there's a big advantage to doing an elevated radial system. And 4 radials seems to be a good number to go. I'd go with 4 at least rather than 2. And a couple things to think about it though. Here's some graphs they have, and I think again the IRL manual talks about it. If you take a look at this right here, there's some capacitive effects going down here, allowing the current to come back up through there. And that made me think a little bit when I looked at it. That implies if the more radials we put out there, the more capacitive effect we would get, and therefore maybe the more efficient the antenna would be. And in fact, when I started reading a little bit, N6LF says they can be effective, but don't use too few. Elevated radial systems are subject to a number of ills. They're very sensitive to details of layout, soil characteristics, nearby conductors, coupling to feed lines, and other factors. Like ground radials, elevated radial systems work much better if the screen's not too sparse. In other words, try to use 12 or more radials, you'd be much more happier. And I think he might be onto something there too. He did a series of 5 QEX articles, and all of them are on his website. I pulled some of these lessons learned, if you will, comments about it that he made. Try to use at least 16 quarter wave radials. If you got bad ground like we do here, and as was just mentioned a minute ago, it seems to work better if you got bad ground to do 32 or more. You don't have space for quarter radials, lay down a large number of shorter ones. Shorter your antenna, the more you need a good ground system. Poorer your soil, the more you need a good ground system. And that thing, work hard at making the antenna itself more efficient. Pay attention to that radiation resistance, even though you can't see it. And another thing that some people with, he actually had one of these step IR verticals, I think. And I know a guy down here in Aiken, South Carolina. A couple of them have them down there, and they've seen that as they added radials, they had to retune their antennas because of it. So when you start adding radials, your resonance, your frequency may change a little bit. Just be aware of that. Some of my comments about it: people too often try to find one magic antenna. If you're a contester, DXer, contester particularly, you ought to have more than one antenna per band to have it let you cover all the different takeoff angles. Too often, somebody will put up a vertical antenna, and as we saw, they're low angle radiation beasties, and they want to talk to somebody in, say, Ohio from South Carolina, or from Mississippi, they want to talk to somebody in Pennsylvania, and the vertical doesn't work very well for that. And they get a little bit perturbed. They say, oh, my antenna doesn't work worth a darn. It's because they don't know anything about takeoff angles. So just because somebody tells you their antenna doesn't work very well, don't necessarily believe until you do your own research. If you got a multi-band elevated vertical, require tuned radials for each band. You can't just have the one. And multi-band verticals set up problems with Baluns too, which is another topic. K2AV talks about keeping the wire 15 feet away from the tree trunk if you can, if you're using that for support of a wire. And I think it was, who was that, Larry? K7RF? RL?
Okay, yeah. about the folded.
Yeah, well, we'll get to the folded dipoles, but he also talked, I think what he referenced was, yeah, 50 feet away or something like that. I think you're supposed to have 50 feet away too.
No.
Maybe he didn't do that. Use a Balun or another
article, wasn't it?
Yeah, somewhere in an article. Use a Balun at the base of the antenna. Consider a second Balun in the shack. I do that for my inverted L. I've got the Balun right out there at the base of the tree, but then also, since my coax runs just barely under the surface of the ground back into the shack, and 160 and 80 meter penetrate deep into the ground, I also put a line isolator in the shack where it comes into the shack to help kill anything that might have been a common mode that might have been induced on the shield as well. I don't have any issues with any type of RFI coming in on that feed line. Elevated verticals work very well, but those things are kind of hard to erect at 40, 80, and 160 meters. Now, when I started looking at this, this was a decision I made for a compromise. I didn't want to give up height. And we talk about folded counterpoises briefly. Well, Again, I encourage you to go to K2AV's site to read about them, but they're very critical in their construction. Some people like them, some people don't. Usually the ones that don't are the ones who deviated from his construction plans. You got to follow it directly, even down to the size of the wire. He recommends number 12 wire and says 14 doesn't work as well. You wouldn't think that's the case, but it does. And people who don't like the folded counterpoises oftentimes make changes like that, or don't follow his advice to keep 5 or 10 feet from the folded counterpoise to any vegetation. He said he used to run it right through the trees, and he found out he lost quite a bit of signal by doing that and caused him problems. So he's actually made a tunnel through his trees to accommodate the folded counterpoise. For those of you who aren't familiar with it, rather than doing a radial system, you use an elevated radial, and you fold it over and use a transformer in it to shorten the length of the counterpoise down much shorter. And they work well, but even he admits that they don't do as well as a ground radial system. So I decided to stick with them. But when I started looking at should I use elevated radials or not on 48,860 meters, and I looked at that graph of radiation resistance, I didn't want to give up the extra 10 feet I would need to do an elevated radial system. So I elected to do the ground instead. We do have some people here that are using 40-meter ground planes here in South Carolina and doing excellent work. N4XL is a German guy over here working for BMW, and he is a great contester. Look him up on some of his scores, and he's gotten very good luck out of it. And he's talked to another guy, Bill, N4IQ, into setting one up, and they're doing real well. That's fine for 40, but on 80 and 160, I've only got a 65-foot tree, and I don't want to give up that extra height for radiation resistance. And that's, again, the purpose of this thing is to be aware of what happens when you start making compromises on things. You give up one thing when you make a choice that maybe it doesn't work out for you in the overall picture of things. Have a low dipolar V for close-in contacts. I've got a 40-meter inverted V at 35 feet. Oftentimes that works much better for in-state contacts or next door adjacent state. And if you do an auto tuner, put it at the base of the antenna. Inverted L, make the section as tall as you can for DX. And another thing that comes into play, you can model this, and it's proven out signal-wise too. The horizontal section, keep it as flat as possible, and you'll get a 2 dB gain opposite direction of the horizontal wire. And I seem to see that a little bit in that my signals, could be the radial systems, I don't really know, but my signals seem to be going much stronger on 80 and 160 into, from where I'm at in South Carolina into Illinois, Ohio, Michigan, Minnesota, those directions. And horizontal section should not fold over a tree. We mentioned that as well too. The horizontal section gives you high angle radiation. I like that for domestic contacts. First inverted L I put up was 30-foot tall and 100-foot across, and it didn't work worth a darn for DX, but I could work South Carolina and Georgia with it, North Carolina pretty well, but that's not what I wanted. And also be aware that if you, like my 160-meter L, if I use it on 80 meters, you're going to get different lobes thrown out in a different pattern, and they may help you or they may hurt you. Don't know. You may have to do some modeling or swing that top loading thing around a little bit, horizontal section, and try to get your lobe to move in a different direction if you don't model anything. So just something to be aware of. Some other things briefly, we talked about the folded counterpoises. You can fit those things in a 66-foot space. K7RL really likes his. I read his email, and I'm sure he'd be happy to talk about them. I've got a guy down here in Aiken who likes them as well. He's running 2 of them and significantly improved his 160-meter place. He lives in a mostly housing restricted area, but he's able to sneak some wires up in the trees, and he's really done well with folded counterpoises. I've talked to 3 or 4 other people here in the state that weren't happy with them and gave up and went back to radial systems. So kind of a hit or miss, depending upon how you install them, is what the impression I've got on them. A lot of people like the 43-foot vertical. talk about them. It's the latest catchy type of thing, but look at this. This is the 10-meter takeoff angle for 43-foot vertical. Don't you want 10 meters takeoff angles to be down in here? Doesn't work very well for that. It isn't until you get into about the 40-meter, 20-meter, and 40, 80, and 160-meter range that it begins to act more like a vertical. So I wasn't keen on that. I looked at that too, thought, well, maybe I can put a 43-foot vertical up the way it seems like them, but that turned me right off from it. You can also phase verticals. I'm sure you all know about that. This shows two. The only thing about that I wanted to mention basically was if you're going to think you might end up phasing verticals and you got a small lot like I do, plan out where you want the first one to go so you don't have to redo everything making the second one. Any questions? And that was pretty much a presentation.
That was great, Kevin. And so, yes, we have several. And wow, that's cool.
That's my ground. You can't even see those grooves now.
Amazing. Okay, so we have some comments and some questions, and I put it in the chat room. I mentioned people. I'll spool out the questions and the comments and just see what your reaction is. If the people who asked these wanted to, then we can allow them to chime in. So we got the information about the ground radial, and got that business going on. And let's see here. Tom says a gap Titan has elevated radials and works very well. And I know you mentioned that. That's sort of a general statement.
Well, what I will say on that is it's the old adage of your mileage may vary. And by saying these types of things, I'm not saying that your radio doesn't work, your antenna doesn't work, etc. But if you look at the measured data for installing per the manufacturer's instruction, that gap Titan had like a minus 20 dB gain over a quarter wave monopole. And the multiband ones only had about a minus 6 dB gain. If you use an elevated radial system, 2 or 4 radials compensates and makes up for a lot of the ground losses that occur. However, I'm going to hazard a guess that you don't get as much gain out of getting an elevated radial system with a Titan as you would going from a Titan to a quarter wave monopole. So keep in mind, are you comparing apples to apples or apples to oranges?
Yeah, and the earth is different in different places, isn't it?
Yep.
Okay, here's a question from John, NN5 Tango. I like these NN5 calls. Those must be great operators. Well, the question is, how critically do you tune the elevated radials?
I do. I disconnect all but one and tune it up. But is it critical? I'm going to tell you, no, it's not for my application. And I'm going to commit some heresy here and tell you that I am using an auto tuner at the base of my vertical out there. I want to get away from that. But right now, that's what I'm doing so that I can get increased bandwidth on my 80-meter elevated vertical. And as such, having it tuned is not critical to me. But before, when I had my other elevated configuration, I actually went out there and tuned each of the radials one by one and connect them back up. And it seemed to make a difference. But if you haven't gathered through the presentation, I'm not a perfectionist, and I follow YT's K9 YC's advice. Don't let your ability to put a perfect one up keep you from doing an effective one.
Comment?
Yeah.
N8 King Henry. Once again, simulations in ANSOF's HFSS program indicate that it doesn't really matter whether the radials are tuned or not, and you get almost all the bang for the buck for putting in about 30, 32 radials, only 1/10 of a wavelength long.
Okay, that makes sense. Did you do anything with elevated radials?
No.
We were discussing about tuning elevated radials is where we were at, I think.
Well, if you're farther away from the ground, it's the reason your ground losses are going to go down. So maybe you don't need quite as many radials if you're elevated. And I don't have any data on that. I only simulated, you know, some number of radials and different types of radials for a ground mounted.
Yeah.
With craptastic Florida soil, which is about the same as your craptastic South Carolina soil.
Yeah. All right. So back to the other, I think for elevated radials, you do get out of it a tune configuration. I even staggered a couple of mine, tried staggering a couple of mine to give me wider bandwidth by having two of them be a little bit shorter than the other two, which are a little bit longer. And I seemed to get better bandwidth, but I think that was a trade-off in that I ended up not getting quite the antenna efficiency, but I didn't measure it. I don't really know on that. Modeling would probably be your best friend in this.
And Kevin, I don't know if you're looking to open the chat window yourself, but we have a lot of questions and comments. I think this will be good for the whole audience. Again, same person, John, NN5T says, is mixing of elevated and ground radials a no-no?
I can't answer that question. I would think that you wouldn't get much benefit at all or any significant amount of benefit. However, I did read some comments that people said if they salted the ground underneath their elevated systems, they did see an improvement, and it was made available with NEC, which makes sense because let me share this screen again.
2 drives ago, a takeaway for the Chicago.
Hello? How do I share my screen? And there it is.
Comment?
Yeah, go ahead while I'm going back.
I think it's not a no-no. The whole purpose of the radials is to basically shield the ground to reduce ground losses. And whether or not they're elevated radials or radials on the ground, anything that happens to shield the ground is a very, very good thing to reduce ground losses. And so for NN5T's second question, I think the answer is no, it's not a no-no. Go ahead and do it. Put as many as you can.
Another comment?
Before we go, let's get the second comment. Let me say this graph right here, I would tend to think that by reducing this resistance in here, you end up helping that return current through these individual things, giving you a slightly stronger signal. Who was the other comment?
K4RO here. I remember ON4UN at Dayton giving a talk, this may have been 20 years ago, and he said, like you just explained, that the additional ground screen underneath will help reduce earth losses, as he put it. The question that came to him was, should they be connected? And in other words, the ground screen and the elevated radials above it. And if I recall correctly, the answer was no, don't connect them. And I'd like anybody to chime in on that if they have a better memory.
I'll chime in on that, not from his perspective, but from the fact that I couldn't get my elevated radial vertical to work well. And I went out there and looked at it, and I had crossed one of the wires and actually grounded one of the radials to my tower, and it didn't work worth a darn.
Sounds like a vote for no. Don't connect them.
Well, I have another vote for it doesn't matter. Basically, if you've got a very high conductivity ground by putting in any radials at all, you shield the earth losses, the ground losses. And I don't think it matters much whether your ground systems are connected at all. As a matter of fact, just laying in the ground radials so that you've got a very highly conductive earth underneath your antenna is a huge benefit.
The question I have, can you hear me or not? Yeah, I'm not muted. Question that is being asked there is, if this is, think of this as the driven element, and this is the second half of the dipole, you take essentially got a V-shaped dipole here with your center coax connected to here and the ground connected to there. What happens if you take and you ground that? If you ground that, you're grounding the center part of your coax. So if you try to ground these two things, that may have an effect. I don't really know. I know what mine didn't work worth a darn, but if you do just the shield, then maybe it wouldn't.
Kevin, that would be devastating. But
Yeah.
what I was commenting on is, let's suppose you've got some elevated radials, and in addition to that, you put in a bunch of wires just laying on the ground. The wires just laying on the ground, even if they're not connected to anything, since they're highly conductive, shield the ground so you prevent the ground losses in the near field. And that's the big win.
We got that. What's
It's
your
like soil doping.
Yeah, what's your thought on connecting those wires laying on the ground to the actual elevated radial part? That's what the question is.
I haven't simulated it, so I don't know, but my intuition is it doesn't matter whether they're connected or not. The big win is just shielding the ground by having that highly conductive ground surface.
Okay. Yep, that's kind of where we're at too. It acts like doping. Let me go down this list here and says, will the copy of the presentation be available to download? I think, Larry, you're putting that on YouTube, right?
Yeah, we're putting this presentation, but I think the John's question was K9EL was the copy of the slides that you're using. I think that's
Oh,
what
I
they're doing.
can give
So
it
that-
to you if you got a website for it, but I don't have my own website, sorry.
Yeah, we can post. Actually, we can post that. Probably John McVeigh can put that on our Dixie site. But what we do is to make sure we have a mechanism for letting everybody know. But if there's sufficient interest in having Kevin's slides, I think they'll be great. This has been a fabulous conversation so far.
I got to add one thing about my slides though. If you notice, sometimes I'd click and things would appear on it. I have embedded animations. And if you just print this out, you're not going to see them. It's got to run under a PowerPoint presentation. Sorry.
But having any of it is better
Yeah.
than having none of it, right?
All right.
There is a way to embed a PowerPoint presentation on a website. I've done it before with my reunion website, and I had like 300 slides. And there's a Microsoft tool that you can use to embed that on your page, and then anybody that clicks on it can actually watch the presentation with all the transitions and everything.
Great.
Okay, well, that'll be good. We can work on that. Let's move on here. And so Matt, and you probably see this, Kevin.
Yeah,
Matt,
I see him now.
okay, why don't you address that one?
Okay, Matt, if you don't have a tuner for the base, where could I find instructions for loading coils? I'm going to throw that out to somebody else. I haven't researched that yet. Anybody want to pick that one up?
I'm wondering if Matt is talking about like a step-by-step how?
Yeah, how to wind
Where
up.
to start? What size conductor to get, what size of coil form to get, what's about the spacing, the length of wire, then what you connect it to. So I'm
not
that
the
could be-
genius on that, so I'm going to say look on the internet. I'm sorry.
that's it.
Comments?
Yeah, go
TLA, you can
Good.
design an L network or figure your coil inductance requirement there. Then there's a chart for the other.
I know you can find them, but I can't tell them where to go to get them.
Okay, suppose
Let's see, what's Fred got? How about adding a ground screen to existing radials? Yeah, 4x4 welded wire fencing. How does that affect the ground resistance?
can I answer the previous question?
Sure.
So use a network analyzer and figure out what the impedance of the antenna is. And if it's short, it's going to be capacitive. And that's why you need an inductive loading coil to bring it back towards resonance. Now, the best coils, the very best coils, the highest Q coils, have roughly the spacing between the wires exactly equal to the wire diameter. And the next thing you want to do to achieve highest Q is to adjust the coil diameter so that the length of the coil and the coil diameter are roughly the same in order that they fit into a sphere. So figure out how much inductance you need, and then figure out, you know, with the biggest wire you're going to use to wind the coil, what its diameter and length needs to be. And the highest Q coil is going to get you the lowest losses. That's the answer to how to build your coil. Then you measure the impedance again, and it's going to be very low. And so you need to step it up with a transformer. And you can just figure out what transformer tax you need to step it up from whatever that very, very low impedance is to roughly 50 ohms.
I'm thinking when I listen to this conversation, I'm thinking about my days when I was a novice and became a general way back in the 70s. I was not an extra, but and so even though I had taught electricity and electronics, I didn't understand how that related to my wanting to make a nice vertical that worked to suit me in the place where I was located. So without having an elder there to help me, all of the discussion of theory in the world is of minimal value. I don't have a network analyzer. I'm not even sure I know what one is. Of course, I did live just down the road from MFJ, but I guess what I'm saying is there probably is a space for taking a lot of what Kevin has said and what we've discussed in the later hours and figuring a way to boil it down to something that's simple that may work in your location, but consider these things. Does that make any sense at all?
Yes, I understand you, but now network analyzers have become cheap. Go get yourself a nano VFO. Excuse me, not nano VFO. Nano, what do they call it? Nano
VNA.
Nano VNA. That is a vector network analyzer, and they're pretty good for the money.
I just think about some of the hams who want to do good, even contesting. Now, they may have gone to a superstation or somebody else's station and worked a contest and been pleased with it, but then they go back home and they get in their yard, and they're not even sure how to know what tools they don't have or to get. And I think that's what I'm saying. What we're saying here is really good information, but to the person who's not hearing this conversation, it can be a little bit cloudy. So maybe there's a vacuum in the middle or a space in the middle for some of us to fill that void. Kevin, let's go on with more questions.
All righty, you're kind of there with what you're saying, talking about why I did this presentation in the first place. Can't cover everything though. Let's see. Madam, I hope that helps you a bit.
Did you add fields?
It's clear as mud.
Let's see, added 4x4 welded wire fencing. How does that affect the ground resistance? Fred, I'm going to say that'll definitely lower the ground resistance. Ground screens have worked very well for lower for verticals quite often. And in fact, that's touted by a lot of people. But most of us don't have the resource and ability to go out and lay the front yard or backyard with screen fencing. But if I could, that'd be a good way to do it. I would prefer to use copper or something, but a lot of people have been going out and just buying the fencing. You can buy at Tractor Supply and laying it out, and they're happy with it. So I think that would definitely be worthwhile doing. Let's see, Jim, wire on the ground is the velocity factor less than air. As you add radials, your SWR low point should decrease in frequency. When it stops changing, you had enough. Well, that's true, Jim. But again, some of the premise of this to begin with was I wanted to have a clue for how many radials was I going to put out to start with. And I decided I had to go out and buy the wire and this, that, and the other. I do add more, but at least had a starting point to figure out. I wanted to at least have 32 radials, and that ought to give me a good enough antenna for contesting, and then I'll improve it more. I'll just lay more and more out. So you're following a good tried and true method, and that definitely works. Let's see, an N5T, high gain, high tower insulation is the 8-foot ground rods, no ground radial. Didn't work. No, I've heard that type of stuff before too. You need a radial system to go out and collect the stuff for quite a ways. J68HZ, thanks, Doc. Glad you're tuned in for us. Yeah, the neck 2 doesn't do very well. Don't know if you caught the beginning, but we talked a little bit about laying some 8 radials out, and that if you looked at the chart, it said calculated neck calculating only said you got a 1 dB difference between 8 radials and 64, but then Rudy went out there and found out you get about actually 3 dB difference going from 8 to 32. So neck 2 is not a good one for that. Nano VNA was definitely what we're looking for, Matt. That'll help you out, get you to the value you need for the coil. And then best I can say is find a book, go out on the internet. I know I've seen videos and how-to in different places. I just can't tell you where to go and haven't done it before. Joe Fritter, K7JOE, simple question. Put up a top end 160L, deer toward the old one up. Yeah, that's a problem around here too. 3/8 lambda radiating element, 70 feet up, 125 feet across, 4 elevated radials, 132 foot long. Okay. Faster to not duct. Any recommendations what to do or not? Feed with RG6 coax. Grabbed a 1,000-foot roll for $18. Well, I think if you've got 4 elevated radials and how you're doing, if you're happy with it, I think that I'd just let it go. One thing I would say is if you're, didn't say how tall your elevated radials are, but make sure they clear the deer antlers is about the best thing I can say. Anybody else have any comments on that? Yeah.
Jim, N3JT, I'm looking at the chat questions on the right here on my screen. You may have skipped mine. May I ask you now?
Sure, sorry.
I'm using on 80 meters, what I call a ground plane, and it's two elevated radials about 8 feet above the ground. Does quite well, comparatively. But you've convinced me that maybe I should add 2 more radials. But the question I have involves your important point, which was to have an un at the feed point of that antenna. I do not. Instead, about 10 feet away from the feed point, I have a very large toroid wrapped with about 12 or 14 turns of coax. And I think there's another one in the shack here, but the shack is so messy, I can't tell where it is anymore. So the question is, am I doing as much as the un would be doing? Because I think that's all that is inside an un basically is a toroid, right?
Yep. Well, yeah, but there's, from my research into Balun, first off, I'm not a technical genius if you haven't figured that out. I've got some understanding of the key points and I'm completely ignorant in others, but I did do a presentation on Baluns too, which I may give to the group if you're interested. And one of the things that comes out about it is there's a reactive and a resistive component to Baluns. And I can't tell from your description if your toroid, that with your un actually has a good resistive component to the to its construction. So I would be interested to take a look at that, or I would probably do a little more research into that and figure out just how much resistance it has. That's one of the biggest things that kills things is your Baluns end up being reactive at your frequency instead of resistance. There's a G3, I think it's TXQ, who has a website that talks about that. And K9YC also has like a 40-page booklet that talks about winding, his practical experience for winding toroids to give you good resistance capabilities and opposition to current flow. So that's my main concern, is whether or not your windings on your toroid is good for it, especially if you're running power, which I recognize your call, and I'm going to guess that you are. If that's not the case, I'd look at that a little bit. Yeah.
No, you're right. And I do have an RFI problem into my laptop. Only affects N1mm, I might add.
Oh, ouch.
It locks up on occasion. So that's why I'm focusing on this issue.
Yeah.
And what's your mix recipe on your toroid? Because that'll have a big indication.
Material 31.
Yeah, material 31 is not very good on 80 and 160, my experience.
That's more higher frequency.
Yeah, you might try changing your mix recipe on the toroid, especially the one of the antenna.
Actually,
it full?
the curves that I saw suggested that it was better at the lower frequencies.
Maybe it's 33.
Yeah, it's normally a mix. I think it's mix J or mix 75. At least that's what I found. I have the same issue here.
I'm not sharing my screen anymore, am I? Yeah. I'd look at that, Jim.
Say again?
I see. I would look at whether your winding and configuration is good enough. Now let me go back up here to the top. Where are we at? Big welcome.
Hey, Jim, are all of the cables in your laptop? Do you have those? Do you have those with ferrite chokes on them?
You may not believe this. I spent about $120 on toroids. And if I showed you the shack now, you'd say, where's the shack? All you have are toroids.
So
I have everything. And I'm
close
using in the remote mode, in the remote rig boxes, every cable coming in out of the computer, out of everything has cables wrapped in toroids.
But how close is your 160 antenna to the?
Well,
shack?
in this case, it's more the 80-meter antenna, and the answer is the feed point's about 70 feet away.
Oh.
Give me just a second and I'll pull this Balun toroid thing up and see if I can get any information out of that.
Thanks, DJ, by the way.
Yeah, nice to see you, Jim.
Look at that. We have K1VR staring at the camera also.
And WB5EIN wants to ask a question after a while, but
Give me 1 second here to open this up and share my screen, and you can see what I'm talking about.
Who is WB5EIN?
Larry.
Can you all see this screen?
not
No,
yet.
I didn't hear hit share. There's an extra button there.
I think
This
we
is-
held a funeral for WB5EIN, didn't we? Didn't we
Yeah.
lay him to rest?
Nobody
Yeah.
showed up.
That's right.
All right, so this is part of the other presentation I did. And what this, if you haven't seen this before, G3TXQ has it on his website for 31, and he's using RG58. That is a lower frequency. You're right on that, Jim. I had it confused. Must have been 33. I had the other confused with. But what he pushes, and Jim K9YC, is to operate your baluns in the region where that black line is. That's your resistive region to give you the best amount. But you can see just using this, again, it's 5/8, probably not what you're using. The number of turns affects your balun, your unknown range, essentially, and the resistive range as well. So without knowing it and using some type of chart like this or doing some type of measurement, I wouldn't be able to answer your question, but I'd be suspicious of that right there, especially if you're getting RFI in the shack. There may be some other things. Jim also, K9YC, has a heck of a presentation about a thing called the Pin 1 problem. And if you're not familiar with it, you ought to go to his website and go through his presentation about that. I did a thing on grounding for that, and you end up, you think that your equipment's grounded, but it's really not, and it makes it far more susceptible to RFI because even the cases of our radios aren't shielded correctly. And he's got a few ideas that Ward Silver in his grounding presentation, N0AX, where he talks about they collaborated to come up with Ward's presentation. But Jim goes some extra steps further and recommends actually connecting your equipment and your shack together, your rig to your SWR meter, your rig to your switching boxes, your rig to your amp, which were traditionally thought sets up ground loops, but he makes a pretty compelling case for, in fact, it'll help reduce RFI. So you might take a look at his if you haven't seen that too.
Actually, I wrote an article that was in QST about that, and everything is grounded here. But one curious thing is that the laptop cannot be effectively grounded. It's very hard. There are no connectors on there. And even if you do, like get an RCA to USB adapter and ground the RCA plug to a ground so that you have it. In my case, it didn't help, but it's really hard to ground the laptop.
Yeah. that feed line's where you got to go then, no doubt about it.
Do you suggest it I mean, is it worth spending the money just to try it over what I think I've got that 12 to 14 turns pretty close to that range that you showed, although I'm using RG8U.
Well, I might, if you don't have it, remember I said I both have one at the base, and I also put I use an RF line isolator, one of them what were they, T4s or something like that, in the shack itself. And I have the one that has the ground strap on it. So when it comes into the shack itself, the feed line side is grounded right to my common ground system before it even goes into the rig. You might try something like that.
You don't think the copper strip where it comes into the shack and then goes to a ground post outside is the same?
I am saying, since you have problems in your current configuration, maybe add that extra step to it and see what happens.
The marginal cost, you're right. Okay, good,
Yeah.
thanks.
And I think as I look down there, I got most of the questions. Did I miss anybody you know? Anything else?
Well, these are all great. I think this conversation is just as good as the presentation, and boy, that presentation makes you think. My head's hurting. Tom, back up earlier, said, I don't have space for ground radials for my in-fed vertical. What do I do?
I missed that one. Where is that?
That's above docks, the J68H.
There it is. Don't have space for ground radials on my in-fed vertical. What do I do? Can you get elevated radials in there?
Yeah.
If you can't lay out any radials, then it seems to me you're kind of stuck with dealing with loss of what it is. The whole concept is to reduce the ground loss, and the biggest way to reduce ground loss in a vertical is to use the radials. We had that chart up which showed the comparison that had been done with the vertical book that's put out by Champion Radio, K7LXC and N0AX. And their findings were pretty much, if you can't lay radial systems out, you're going to have a loss system. I can't help more beyond that. Try to find some way to get some radials out. You can try to put up these fake RF grounds, but all they do is help with the RFI problems. They don't help with your signal strength.
There's a question. Yeah, it's a question, I guess, I heard from a lot of people. When we talk about which mix you use for which part, for lower frequencies or higher frequencies, mix 31 or whatever you're using. And so when some people are using, they maybe have one antenna at home, kind of like NN50, only one antenna. So you want to choke in as broad a band as you can. So is it okay to mix those like clamp-on ferrite beads, or should you have, what do you do?
I'm going to be different than a politician to give you a simple answer. You said, is it all right? Yeah.
Okay.
Can I answer that?
Oh, yeah. Yes.
Remember those old tube radios where you had a vertical post with about 5 windings on it to feed the B+ line to the plate of the tubes? Well, each one of those 5 windings was a self-resonant coil. So one of the coils was resonant on 80 meters. The next one was on 40. The next one was on 20, then 15, then 10. And only one of them was really important at a time, depending on which band you were operating on. They were all in series. And the way that worked was they prevented the RF out of the tube from going back into the power supply. And so using different balance, especially air coil choke balance, is exactly the same as that. And if you want to have balance for different bands and you put them in series, and you keep them relatively far away from each other so that they don't have interactions between the two coils, it's exactly the same as those coils on that post that fed the B+ line to the plate of the tubes. And with toroidal coils, which mostly keep the magnetic fields inside the toroid, you can even put them closer to each other, but pay attention to the way that all the antenna tuners do it. They put adjacent toroids 90 degrees to each other to reduce the coupling. You want to do that too.
Oh, yeah. Okay. That makes sense. All right. Tom had another one. You probably saw this, Kevin. I installed a TN, I don't know that, TN07 N-fed vertical for 160 through 6. All have less than 2 to 1 except 75 and 60 meters. I get a 2.5 to 1 there. Any experience on this antenna from the group? That's the same N-fed vertical I guess he's asking about in the other. Okay, Joe has posted something. Tom also has said, okay, back to my mag loop, no ground loss. And let's see if I can go back and see what his original statement was.
Well, you don't have to worry about ground loss with a loop antenna is basically what he's saying.
Okay.
Yeah.
Okay.
And as far as, I don't have the experience with the TN07 N-fed. Somebody here says you don't need radials for an N-fed antenna, and I don't think I really agree with that, but I'm sure it works. I've used them before, but I'm not sure it's the optimal configuration. I think I'd work a little harder getting some radials down personally. What else? I got some information here from Palomar Engineers. Yeah, I stole a lot of their stuff when I was working on that Balun presentation. And he talks about some of this stuff in there. And another friend of mine, N4IQ, has been touting up a company, I think it's called Balun Designs. And he's had very good luck with them. And a lot of the people up there in Greenville, South Carolina have been using those, and they're extremely happy with the
I second
way they work.
the Balun Designs one.
Yeah.
I have that for all of my wire antennas and the 160 antenna that I have here.
They're one of the few out there that evidently post their resistance and impedance graphs as to their baluns that are there. I've used the DX Engineering big baluns that they have, the maxi baluns, and they seem to work pretty well too. But if you go out and you spend like $60 or $40 on a balun, you're probably not getting something that's going to work very well for you in the long run.
Comment on the previous question for N-fed verticals.
Yeah.
The best thing you can do to shield the ground losses is just put a bunch of metal on the ground underneath the antenna. It doesn't even need to be connected to the antenna. The whole purpose of that, the radios, the ground radios, is to shield the antenna from the ground so you don't get the ground losses. And if you just lay down a bunch of wire underneath the N-fed vertical to shield it from the ground, you'd reduce your ground losses and increase your performance.
And even try chicken wire.
Yeah.
As absurd as it sounds, try chicken wire.
Oh yeah, chicken wire or for HF, even something with bigger holes in it.
Well, it's too bad that we aren't on a cruise ship somewhere going and just have this conversation to continue and continue. But I think we probably ought to come to the point of wrapping things up. We have several people who've sent me messages that they have to go, and we have been at it a while. Kevin, I thank you, sir. You continue to amaze me. I'll tell all of you that I've told this story a lot, but I was fortunate to get to be invited as an operator at NQ4I for, I think the first one was maybe a sideband WPX, and then followed up with a CW WPX. And I watched Kevin operate. He's operating alongside VE7ZO, Jim, terrific operators. And I just watched Kevin do magic. That was wonderful. And then it was great. I guess the last Huntsville Hamfest we had that actually was held. So it'd been last year. Got to see Kevan again. And so I really appreciate you, Kevan, and thank you for what you've given on this yet another wonderful presentation. Also, I want to thank all of you who have come and joined in this from other clubs around, and I hope it's meant something to you. We'll be doing more. And then we also, of course, the next we have scheduled, W1VE, is not a member of Deep Dixie Contest Club, but you know, throw that idea out the window. We're just trying to get people together to share information and ideas so we all improve. So again, thanks, Kevan. I appreciate it, brother.
Thank you. Glad to be here and nice to meet y'all.
Yes, thank you. W1VE is Yankee Clipper Contest Club. He had to point that out. PVRC and YCC. Yeah.
Yeah, well, another one of those clubs that we have chased for years and years. So that's okay. Okay, so at this time, I think probably we could carry on for another hour or so, but we're going to go ahead and end this. We'll stop the recording, and I want to thank everyone who has participated, and y'all come back now. You hear it's Elvis, my buddy who grew up about a mile and a half from here.
You're not too far. You're not too far away from my cousins.
Well, that's right. That's exactly right. Down here in God's country. But Elvis would say, thank you very much. So good night to all. We're going to pause the recording right there.